Okay, welcome to lesson 2-3, multiplication rules. Please don't forget that you have a notebook quiz, the next one, so make sure that your notebooks are in order. This will actually encompass 1.4 to 2.3, so it'll have 6 different lessons in there. So you have to go back, make sure you have everything put together. So, all right, but multiplication rules, probability multiplication rules. These are a little more complicated than the addition rules. All right, there are 3 real rules. So, but first of all, let's talk about, when we talked about addition rules, we talked about mutually exclusive and non-mutually exclusive. When we talk about multiplication rules, we're talking about dependent and independent. So they're independent if the fact that A occurs does not affect the probability of B occurring. And they're dependent if their probabilities are linked somehow. All right, and it will be pretty obvious, well, for most of it, when you're reading a problem whether or not they're dependent or independent. So the multiplication rule number 1 is the easiest one. If 2 events are completely independent, you multiply them together. So now, this is an interesting one. Remember with addition I said the or was important? It's another one that 9 times out of 10, if you have the word and, you're dealing with multiplication. All right, so if they're independent, it's the probability of A times the probability of B. If they are dependent, it's the probability of A times the probability of B given A. All right, that sounds a little ominous, but basically, let's just say, I need to think of something off the top of my head. I'm not good at thinking of stuff off the top of my head. Cards. Okay, cards are a big one. Okay, so if I have the probability that, let's say I'm going to draw 2 cards, and I want to know the probability that I will get a heart both times. Okay, given that I don't replace the card. All right, now that's important, the fact that I didn't replace the card. So the first time I have a probability of 13 out of 52 because I have 13 cards. But I've taken a heart out. So that's what it means by the probability of B given A, is that I've taken a heart out. So my second probability is not 13 out of 52. It's 12 out of 52. We multiply those 2 probabilities together to get the probability of getting a heart both ways. Okay, conditional probability. This is probably the hardest one. I'm going to go through the rule really quick with you, and then I'll do it more in depth when we get to the actual example. That's for example 3, by the way. So the probability that the second event occurs, given that the first event has already occurred, can be found by dividing the probability that both events occur by the probability that the first event has occurred. So it's the probability of A and B. So the probability of B given A is the probability of A and B divided by the probability of A. Now sometimes it's really, really easy to find the probability of B given A. For example, that's what we did here. We just found the probability of B given A right there. It was 12 out of 52. I could have gone through this whole formula to find it. Sometimes you actually have to go through the formula to find it because it's not obvious. But if you know it and you can figure it out without using the formula, by all means do. Okay? So, moving on. So multiplication rule number 1. If 37% of high school students said they exercise regularly, find the probability that 5 randomly selected students will say they exercise regularly. And then it says, would you consider this event likely or unlikely to occur? Explain your answer. So with this rule, we're saying that we want to find the probability that 5 randomly selected high school students will say they exercise regularly. Now we're talking about this in general, so we're not talking about taking a student out and not replacing them, okay? So, and it really doesn't matter in this case either, because we're saying each individual student has a 37% chance of saying that yes, they exercise regularly. So the probability that my first student will say they exercise regularly is 37%, 0.37. The probability that my second student is also 37. The third is also 37, the fourth is also 37, and the fifth is also 37. So each one of them has a probability of occurring 37% of the time. Okay? So 37% chance that that student that I picked will say they exercise regularly. Now, find the probability that all 5 of them, so this one and that one and that one and that one and that one occur, I have to multiply them together. Alright, so I have a calculator that does that for me, and I get 0.007. That is 0.7%. Okay? So if I look at this, it should be pretty obvious. Is this event likely or unlikely to occur? I would say it's very, very, very unlikely to occur. That all 5 of my students will say that they exercise regularly. Okay? Alright, let's do a practice problem. Oops. There's your practice problem. Okay? Go ahead and find those probabilities. Okay, here's your solution. Example 2. Now this is going to deal with 2 dependent events. All All right. So it says if 2 cards are selected from a standard deck of 52 cards without replacement, find these probability. Okay, so without replacement means that we're not going to put the card back. If we put the card back, they are now independent because we could still select the same card again. All right, so we're going to do all 3 of these, A, B, and C. So both are spades. So we have a 13 out of 52 chance that the very first card that we select is a spade. Okay, and the second one now, since we've taken a spade, we now have 12 out of 52. We multiply those 2 together, and we end up with 156 over 2,704. I'm sure that could be reduced, but I don't have it written down. So, okay, so let's talk about, now, that was an easy one. Also, C is an easy one. I'm going to do that one with you right now, too. Both are kings. So I have a 4 out of 52 chance that my first one will be a king. Okay, I don't replace it, so now I only have 3 kings left. 3 out of 52, and I end up with 12 out of 2,704. Now, B is a little bit different because it says both of the same suit. So we have to say, okay, so how many suits do we have? We have 4. And the probability of them being the same suits, you notice this goes for spades, all right, is 156 out of 2704. So the probability of it being spades is this. The probability of it being hearts is this. The probability of it being clubs is also this, and the probability of it being diamonds is this. Each one of those suits has the same probability of selecting the exact same card. So we want to know what is the probability that we get either both spades, or we get both spades, both hearts, both diamonds, or both clubs. Now, this you have to read a lot into that. It doesn't say that, okay? But you have to be able to think through this problem and say, okay, when it says both of the same suit, what does that mean? Okay? In this case, I thought through this. I said, okay, well, both of the same suits, so that means they're either hearts, diamonds, clubs, or spades. So if I can think through that and think, okay, that's an or, so we're going to use both multiplication and addition in this problem. Okay, remember what I said earlier? In one of these videos, I said we're combining rules. This is combining rules. So I have 156 over 2704 plus 156 over 2704 plus 156 over 2704 plus 156 over 2704. Okay? So here's my probability that I have both of the same suits. Now the other way I want you to look at that, do you know when you add the same number together, right, you can also turn this into a multiplication problem. We could also write it as 4, oh, my green marker's not, yeah, 4 times 156 over 2704. That's just another way to write that. We multiply them, so I have them down here. So when I actually do this problem, I end up with 674 over 27. That's a probability that if I draw 2 cards out, they'll be the exact same suit. Okay. So your example, okay. Your solution. Okay, number 3. These are the hard ones. I actually need to move. I don't think you can see this. I have a button there. Okay. So it says for the recent year, 99.99% of incarcerated population is adults. And of that, 0.07 is female. If an incarcerated person is selected at random, find the probability that the person is female given that she is adult. So the probability, so normally defined to be the probability of A and B divided by the probability of A. So it says the probability population, okay. Sometimes we have to read more into the problem than what's there. And the fact that it says the 99.99, I would say 99% of the incarcerated population is adults and 7% is female, it's already telling us that. That 7% that's female is also adults. All right. I know it doesn't say that, and it's not written well. It should say 99% of the incarcerated population is adults, and given that 99%, 7% is female. It doesn't say that, but it should. Okay. So it says if an incarcerated person is selected at random, find the probability that is a female given that she is an adult. So if we know, given that she is an adult, that population is 0.99. So for our formula here, we do the probability of A and B over the probability of A. The probability that it's an adult, okay, that's given, is 0.99 or 99%. Now, the probability that she's an adult and a female, we already know that. A lot of times these problems will write this in here already. They'll write it in as one percentage. Okay, they won't write it in as 2, so you have to find both. Sometimes you do, but not always. So this is 0.07. Alright, so the probability that she's an adult and female is 0.07, given that the probability that she's an adult divided by 0.99, okay, is 0.07. By the way, this isn't a great problem, okay? It's there, it exists, but it's not well written. Alright, so here's your practice problem number 3. Okay, go ahead and do this problem. I'm going to walk through this with you just a little bit. If you want to pause it and then go on and try it on your own, you can. So the probability that Sam parks in a no parking zone and gets a parking ticket is 0.06. Remember that they gave this to you. This was really nice. They told you specifically that this is probability of A and B. And the probability that Sam cannot find a legal parking space and has to park in the no parking zone is 0.2. On Tuesday, Sam arrives at school and has to park in a no parking zone. Find the probability that he will get a parking ticket. So this is, use that formula, you should be able to solve it. Alright, so here is our solution. Okay. And that's it for today.